Okay, before we do that, we have to ask ourselves the question, what is Tetris? Well, Tetris is a block game played out on a 10 by 20 grid. You get these nifty Tetronimos that you can spin around and place around the board. You can press a button and a piece will fall until it hits the nearest block down below. And finally, if a row is completely filled, then it gets cleared, and everything above it drops down by however many blocks. Now these basic mechanics are just the tip of the large iceberg of Tetris. What lies below may be too intimidating for newcomers. I wanted to make this project using as little outside code as possible, which means that it's pretty much completely from scratch. The board itself is actually just a list of 20 lists of 10 O's for empty space. For pieces and such, it would just be different letters. Since it's a terminal command console this thing, it prints each element of itself in that order to display the board. So to control the game, you will need to type out your responses into the terminal. But instantly there's a problem in that after each command you need to press enter. Now, how could I possibly find a solution to this? If only I were to be blessed with something. Bless is an easy practical library for making terminal apps, you can read the rest. Basically, Bless can allow me not only to instantly input characters and keys of any kind without needing to press enter, it also allows me to add color and other stuff that I probably didn't get to. After I struggled for 20 minutes wondering why it wouldn't work because I downloaded the wrong version, I was finally able to get it working. You see, even with the colors, you can barely tell where the pieces are when they're O's. Thankfully, we can just switch it to this character. By putting two of them together, it looks like a square, and it doesn't even affect the code because we're still using a list of O's. The square is just what's being printed. Now that it looks much cleaner, we can get on to basic mechanics. Okay, so the most important part of the game are the pieces themselves. By spawning in each piece at a specific place, you can get them on the board, but how do you control these, which are currently just letters on a big list? Well, since the board's only like 200 blocks, it should be easy to just scan through all of them, and if you see a block, move it in your desired direction. But you have to make sure they don't pile up onto each other, so when moving left and right, you need to scan in different directions. If it's going to hit a wall or another piece, then we just tell it not to move. Also, there's quite a lot of glitching and shimmering and flashing and stuff, because I'm printing out the board each time, and that's probably the reason. Great, now your pieces can move left and right, but you see, when we're scanning through, this block doesn't satisfy any of the stopping conditions, unlike other blocks of the same piece, so it'll move. And since we're treating all these blocks individually, it'll not work and it'll be really bad. And an easy fix is just to scan through every block of the piece to see if it's blocked by a piece or a wall. If it's not, then just proceed with the moving. So now that the horizontal motion is set, what about the vertical motion? Well, hard dropping is basically taking a piece down until it hits the nearest surface below it, and then you lock it there. What I did was I found the distances of the nearest surface for all 4 blocks of the piece. Then the amount it would drop at would just be the minimum of all these. Then you delete the old blocks, drop all 4 blocks down, turn those pieces into non-playable pieces, put a new piece, and you're done. Yay. But you're not in fact done actually, because I forgot to mention the most important part of the game, which is that lines actually have to be clearable. So how we do that is we scan each line from the bottom up. If we say that all the blocks are filled, then we add 1 to a variable called line shift, which is how many blocks we must shift down for all the lines above. After we clear all the rows that are full and shift each row down by the value of line shift for that row, then we should have completed board after the line clearing. Perfect! There's just a few more things that we need to do before we can get to. We can add piece randomization, which for now is just total mayhem, and we can also increase the board height because that's a thing apparently. And we're done with our first version. I mean, sure, it may look incredibly displeasing to the eye, but if it works, it works. Well, if you followed so far, congratulations, and thanks for coming along. We've already got the main concepts of the game down, but what lies ahead of us is... I was already anticipating rotation to be the hardest part of the project. Originally, I was planning on just not using SRS at all, and just figuring out some way of using standard rotation. And after attempting to write some very stressful and tedious code, it was evident that it wasn't going to work out for all 7 pieces. Well, 6 actually. You see, the actual rotation part wasn't bad. Just keep an orientation of the pieces, and when you see the piece when scanning, just change it to its rotated configuration. Oh, and change the orientation too. But the problem emerges when pieces can't necessarily rotate like that. For example, when this T piece is touching the edge, you think that it wouldn't be able to turn, but it can. So I tried to cover the possibilities. But this is where SRS comes into play. Browsing online you can find the SRS guide, and there's this really cool table that has the entire foundation of how the rotation system works. So it would first rotate the piece and then scan through each test case to see how it would move it. If there are blocks in its way, it would move on to the next test case, and if it doesn't work for any test cases, then it would not rotate at all. And then implementing this just seems so much easier. I wrote code for general rotation, such as going through all the test cases, checking if it goes out of bounds if pieces or walls block the way, deleting the past piece, putting the new rotated piece in, and changing the orientation. And then it's just more tedious manual labor. There was definitely a better way to do this. Anyways, plugging it all in, this is what I had for my first test with the eyepiece. In which that's not supposed to happen. I did eventually fix it, but it seems like a really interesting concept. Anyways, after fixing it and plugging everything all in, we actually get rotating blocks. At this point, we've already got the bulk of everything done. This is already a suitable Tetris game, but we can add a few more things. First of all, the pieces right now kind of just float there. I'm not going to really dive into the exact details of how we implemented gravity, but it works. It works. And for a soft drop, I just did the same thing, but really fast. I also added a shadow piece, which is pretty much the exact same as the hard drop code, except it doesn't actually place the piece. I also made it so that if you place an entire piece above the 20 block height, or your piece is interfering with the new spawn piece, then it's game over. I couldn't actually figure out how to implement game over. I mean, I could stop the loop, but the thread I used for gravity would just keep on going. I mean, I looked at how to properly kill a thread in Python, but it looks like too much work, so I just called the thread again, so it raises an error and dies. Perfect. Also, we need to actually use 7-bag rotation instead of total mayhem. The queue displayed is only 5 pieces long, but the actual queue is 14. We start with 2 7-bags, and as we use the pieces, if we have 7 pieces left in the queue, then we add a new bag of 7, making it 14 again. Then all that's left is just displaying the queue, which is just under the board. Our final aspect is the hold piece, which is just a separate board. And now we're done. Hello, this is me again, but like a year later, now that I'm actually finishing the video. This is just a demo of the final, or I'd like to say current state of the game, but like I know I'm not gonna get around to actually do anything else on the game. I know this isn't like the most efficient or clean or greatest code out there, but I mean, there's a lot can be optimized now, but for the most part, if it works, it works. I don't care if it's dizzying or it makes you sick. This is my project, I get to decide what it does to you. Anyways, it was really fun to make and I thought it was worth it. Though some parts don't really work quite as well. Given what I was limited to, as well as my method of attack, I think it wasn't bad overall. If you have any suggestions or tips for me to learn from, please tell me. I think back when I did this, I don't think I've done a project like that in a while, so pretty cool that I actually made this, I guess. There's also like a ton of stuff and like bugs that I fixed and workarounds I didn't quite get to mentioning, but I don't think it would have made like all the difference in the world. So remember that bug back when I was doing the rotations with the eyepiece, how it would cross over to the other side of the board? Well, I'm looking over my script here, and I wrote way back, and it says that I'm planning to make another video about that glitch, because I made a separate version that would allow pieces to cross over to the other side of the board. I am definitely not going to do that, but I guess here's just the project on the screen. It's pretty cool, I guess. I don't think there's too much usefulness. I mean, it could probably help with finding some PC solves, yeah, but I think that's it. Bye.